So, welcome everybody to the second panel in this afternoon session. We're here to discuss careers in data science and energy. Very excited about this one. For the ones joining us right now, my name is Andreas. I'm the head of the Helmholtz Information and Data Science Academy, which is the rooftop organization of all the Helmholtz Information and Data Science schools, bringing this virtual career fair to you and to give you an overview of all the great opportunities where you can apply your information and data science skill sets to real life and life-changing questions of the future. So one of these field of question obviously is energy, and I'm very happy to have with me Nina Rohringer from the DESY, Alexander Mitsos from Jülich, and Caleb Phipps from the Cultural Institute of Technology. So grateful for you guys to be with us and give us a little glimpse inside your research. We would love for you to introduce to the audience very briefly what you're working on, and then we can discuss what could be interesting for the audience. Nina, you want to start?
Yes, hello to everyone. Welcome to this panel discussion. My name is Nina Rohringer. I'm professor for theoretical physics at University Hamburg, Universität Hamburg, and I'm lead scientist at DESY. DESY is a national research laboratory in Hamburg, and we offer a complete portfolio of large-scale facilities in order to investigate materials and also biological systems that might be actually interesting in energy applications.
Wonderful. Thank you so much. Alexander, what about you? What are you focused on?
Hello, everyone. My name is Alexander Mitsoss. I'm a professor of process systems engineering in Aachen, in RWTH Aachen University, and I'm also director of energy systems engineering in Jülich, in Forschungszentrum Jülich. What I work on data science is mostly the combination of data science techniques with global optimization, and we use that to optimize energy and chemical systems.
That sounds very cool. I'm so excited to hear more about that later. Caleb, welcome. What about you? What are you working on?
Yeah, so my name is Caleb Phipps. I'm from the Karlsruhe Institute of Technology, and I'm at the opposite end of the spectrum. I'm just starting my career in data science. I'm been a PhD student for almost a year now at the Institute for Automation and Applied Informatics, and I'm focusing on time series data analysis with uncertainty. So how can we take the uncertainty that is associated with any forecast in the future, for example, and make that more open to the people so they can see this uncertainty, visualize this uncertainty, and use that to, of course, deal with all the uncertainties that come when we have an energy system full of renewable sources. Yeah.
All right, so you are actually still in one of the grad programs, so I'm pretty sure that the audience is very interested to hear about your experience so far. Maybe can you elaborate a little bit more? How did you find out about this Helmholtz grad program combining data science and energy research, and what made you join the program?
Well, it was actually, I found it was more through my institute here. In my master degree, I took a few lectures, was run by the institute leader, Veit Hagemeyer, and I found the topics that they presented in the lectures, the research topics, really fascinating. And then I had a discussion and I said, you know, I'd really love to look into the applications for energy with data science, and that was how I got the opportunity to come into the position I'm in at the moment. Yeah.
Okay. So everyone, let me remind you again of the chat that we have, where you can post all your questions for the panel or individual members of the panel. Just post them during the discussion, and Victoria will read the best ones after the intro session. So Nina, you are a principal investigator in the DASHH school. Can you explain a little bit what DASHH is and what makes it so unique and what your position there is?
Yeah, I'm happy to present DASHH to you. DASHH is an interdisciplinary graduate school that is focused around the general topics of the structure of matter, how we can investigate structure of matter, and it interfaces challenges of physics, structural biology towards the data sciences and also applied mathematics backgrounds. So we have a very broad portfolio of research projects within DASHH that range from elementary particle physics. So we have a few DASHH PIs that are really at the forefront of experiments at the Large Hadron Collider, both in ATLAS and CMS experiments. We have a lot of projects in the area of photon science, where we employ X-rays to investigate the structure of matter. Here in Hamburg, we have excellent sources to do so. We have one of the brightest synchrotron radiation sources that provide X-ray light, and many beam lines means experimental stations for investigating structure of matter. That ranges from I'm looking into superconductor, into materials, energy-related materials, for instance, energy storage in batteries, looking into microscopic processes of battery charging, and basically up to structural biology to look into the secrets of photosynthesis and trying to understand molecular, macromolecular catalytic processes. Moreover, we have new X-ray sources in Hamburg that are called X-ray free electron lasers that are even brighter in the emission of X-ray light than synchrotron radiation laboratories. And with all of these new sources, there come many challenges to us. So
there are a lot of different approaches to the question of energy, I can hear. But great, thank you for giving a little overview of the DASHH. Alexander, what about you? You're involved in the school as well?
Yes, I'm one of the directors of HDS Lee. You can think of Lee as Bruce Lee, whereas for us, Lee stands for Life, Earth, and Energy. I represent Aachen in the school. I'm a director responsible for RWTH Aachen. Wolfgang Wichert is the director on the Jülich side. Other partners, in addition to Jülich and Aachen, are DLR and MPI and University of Cologne. And as the name indicates, we cover not only energy, we also cover life and earth. So we are a very broad school in terms of thematic applications. And you may think, how can you possibly have one school around all of this? Well, when we were thinking about the proposal and we devised the school, we realized that all these three disciplines have similar challenges in respect to data science. We all have to deal with heterogeneous data, large-scale data, sometimes not enough data, and we need techniques to deal with these challenges. So we have put together a team of both applicants and theoreticians, so people from machine learning, from mathematics, from computing, from informatics, or computer science in English. And this is really exciting, and we try to answer things like, how should the energy system look like? And to do that, we need to have models, and we need to account for uncertainty in the data, such as weather prediction or cost of electricity.
Okay. So Caleb, that kind of sounds like once you're done with your PhD at Karlsruhe, you can directly join Alex's team in Jülich, right?
Sounds possible, yeah.
If I Hagemeyer says is good.
Okay.
So can you expand a little bit, Caleb, about your work? You talked about time series in energy systems. How do you assess this kind of data? I mean, do you go around collecting data from the meters, or what could I expect if I would look over your shoulder for a day? What do you do?
So what I've been working on for the past few months is, as I said, all about uncertainty. And so the standard way of forecasting uncertainty is you make a point forecast and then you estimate the variance of the errors, and then you get like an uncertain output. And I've actually been trying to take uncertain inputs, so special weather forecasts from the European Centre for Medium-Term Weather Forecasting, they're called Ensemble prediction systems, and propagate the uncertainty through to my forecast. And yeah, as you mentioned, the hardest part of this whole process is getting the data. You have to apply for licenses, you have to download from a wonderful storage center which has magnetic tapes, and you wait sometimes in a queue for 2 weeks before the robot has time to load the tape. But yeah, once the data's there and once it's all pre-processed, then it's a lot of programming, running, rerunning, trying to figure out why it didn't work, and hoping that at the end something usable comes out.
Vision, what you want to accomplish in your life as a researcher? Is there some question that you're particularly focused on?
I'd say for me, I mean, my main focus is how can I help integrate more renewable energy sources into the smart grids, into the energy system. And whatever I can do to try and help that. I mean, the idea of uncertainty is when we can quantify the uncertainty, it'll be easier to install sector coupling, so power to gas devices. It'll be easier to use electrical vehicles. It'll be easier to schedule dispatch and everything. So my idea is anything I can do to help increase the percentage of renewables in the grid, that's my main aim.
Great, great. I'm pretty sure that a lot of the audience can get behind these goals. What about you, Nina? If you think ahead for the next 10 years, maybe, what are the grand challenges, the visions that you're striving after at the moment?
Well, I mean, there are, I mean, I have several different hats to wear. No, I have the hat as the
Choose one.
one of the spokespersons of DASHH, and representing the needs of DESY. I have the smaller visions for, I mean, what kind of research we are investigating in my specific group. Yeah, so I mean, there's one vision that we have in the moment. We have excellent accelerators at DESY with many, I mean, 1 million control channels. And the one of the big questions is how to operate such a machine. At the moment, we have very skilled people that drive the machine. So if you actually drive an experiment, you want to have this very specific guy driving your X-ray free electron laser, because he knows how to get the best out of the machine. And so at some point, I mean, it would be great to have basically artificial intelligence in the background that could optimize experiments already at the level of accelerators that then are responsible for providing the best possible photon beams. The other big challenge is quite, I mean, a need that we need to address within the next 5 to 10 years is the increasing data flood at these experimental machines. That's likewise, I mean, for the next generation of maybe the Large Hadron Collider as our X-ray sources. I have to look at it a little bit here on my notes. I mean, in the moment we have data rates of 25 terabytes per hour at a typical experiment at the X-ray free electron laser in Hamburg, European XFEL. And we need to come up with new schemes. I mean, already to write out the data at this data level, I mean, is very, very difficult. High energy particle physics are ahead of us. I mean, over many years, they actually learned how to implement so-called trigger systems in their detectors already at the detector level. That sort of does a part of the analysis already at the detector itself, and throws out data and only collects and saves events that are really of physical importance here. And similar schemes have to be invented for science using X-rays.
Okay. So if I would be interested in really high throughput, big data, technical challenges, you would be the person to talk to.
Yes, or at least I could lead you to the people that are directly at the source of these problems.
Perfect. So
I'm not concerned with algorithm development. So this will be another big challenge, is to actually solve what we call inverse problems. To basically get from the measured data to the real physical quantities that you want to describe or measure. And these are often not directly measurable, but there is a so-called inverse problem we have to solve in between. And so this comes along with a lot of applied mathematics and algorithmics, and that's where my personal expertise lies.
Thank you so much. It's amazing what kind of interesting problems there are to tackle. So Alex, basically the same question. What are the grand challenges, the schemes, the let's say science fiction that I could get involved with if I would join your school?
Science fiction, I'm not sure. I'll try to answer science. And rather than talking in general about the school, I'll talk about what I know most in my research. I would say it depends if you are more the math type. If you are the math type, what you can do is we can find together the limits of global optimization coupled with machine learning. Global optimization has been around longer than me, but we still do not understand properly the limits. And I think we're getting close to understanding the limits. And what I mean by limit, I mean which problem is solvable and which problem is not solvable. And I'm not a mathematician that only wants to know if it's solvable or not. I actually want to solve it. And why do I want to solve it? I want to solve it because in the end of the day, we in energy have the vision of a sustainable world, and the world needs energy, and in particular we need fuels. So what excites me but also stresses me is how we're going to get and produce the energy that the world needs every year, every day, every second. And we focus on fuels, and producing sustainable fuels is a major challenge. And it's not only a major challenge for my generation, it's for the generation of students and people, and hopefully we'll solve it by 2050. Otherwise, we're in big trouble.
That's quite a picture you're painting. Thank you a lot for that. So we got a very nice overview of your research areas. I'm pretty sure there will be exciting questions in the chat. How are we looking there, Victoria?
Yeah, we got very interesting question from our international participants. And one of the questions is from Anna. And Anna's asking, what programming languages would you recommend to learn to those who want to make a career in machine learning and or data science?
Alex, yeah.
So I'll start. I think I'm the oldest in the panel. So I'll start by sounding like an old guy, and I'll say what happened when I started. So when I started studying in Karlsruhe, I did not know anything about programming, and I had the choice between Pascal, Fortran 77, and C++. The computer scientist told me, don't do C++, you need to know C before you learn C++. Turns out this is wrong, but I listened to him. So I had the choice between Fortran and Pascal. And Fortran 77, as the name suggests, had been around since 77. So people told me, oh, this is old school, don't do this. So I ended up with Pascal. And I'm pretty sure none of you have heard Pascal, because since I did this course, I never used it, and nobody, I think, anymore. And people still use Fortran. So my answer, Anna, would be learn a programming language well, and then the next programming language will not be as hard. I use Fortran, I use C++, I use Python, I use Perl. You can do whatever you like. And I think I leave the younger panelists to answer what is the best language now. For sure, I would learn Python right now if I were you. But I would also try, one of the more classical ones.
Do you agree, Caleb?
For real number crunching problems, and I mean, to really, if you have a really high, parallelized computer program, I mean C++ or even Fortran, are still the good choices. I mean, for really highly parallelized programs. I mean, if it really goes into number crunching, where you need, I mean, you really need to know, I mean, how to, I mean, also the compilers very well at some point in order to program in that way. I mean, that is directly geared towards the machine that is in the end doing your computation.
Okay. So Caleb, what are you working with? What is your language of choice?
Well, I've actually come from a statistics background, so I used a lot of R, very statistical based language, but the more machine learning I do, the more Python I do. So that's the trendy language at the moment, you could say. Okay. But I agree. A good basis in, I've also learned Java and C++, so having a basis in one of those old-fashioned object-oriented languages is probably definitely a good idea. All the languages are similar, so once you can do one of them, you can sort of learn the others.
All right, thank you. We got some more questions?
Yeah, we have a question for you, Caleb, again. And the question is from Felix, and he's asking, what statistical stochastic methods do you use for working with uncertainty? And do you think that incorporating uncertainty is becoming more widely used?
Yeah, so yeah, as I mentioned, I've been working with so-called ensemble prediction systems. If you go into the ECMWF website, you'll see a really nice description about how they are created. And so my approach has been to take these ensemble prediction systems. You end up getting 51 different predictions for a future weather variable. I've been taking the uncertainty, because when you have 51 predictions, you can build a probability distribution over them. I've been trying to propagate this uncertainty through to forecasts for wind power or solar generation, etc. So that's not the typical statistical approach where you would assume a distribution, or maybe with the pinball loss function directly approximate a quantile. So that's my approach. It's a little bit different. And I think definitely uncertainty is becoming more and more popular in the energy systems. There's the whole, there's stochastic power flow optimization is a big field at the moment. Even, for example, for electrical vehicle charging, there's a desire from companies to give their consumers the option, maybe if they're slightly like to live on the edge, then they could select that only 70% of the time their battery is full, and then we can use more power in vehicle to grid. Or there might be somebody who was very risico averse, and they're going to select 99%. And if you have the probability information in the prediction, you don't have to create multiple predictions. You can just draw a different quantile and propagate that through. So I definitely think uncertainty is being considered more and more often.
All right. One more?
Yeah, we have further questions, and the next one is from Aswin, and it's asking, I'm an astrophysics grad specializing in space exploration.
Yes.
And I'm interested to know of data science career opportunities in energy sector. What do they actually look for in data science? So what kind of data science they're looking for?
Alex, what do you think?
What type of data science will look, or what type of data scientist will look? Scientist. So one of our PIs in HDSL is actually, and Dirk Without is his name. He's a professor whose main affiliation is UNIC, and he's a physicist, but what he does is he does statistical analysis of data. So what I would say we're looking for smart, creative people. And what you need to bring in, I think, is math knowledge, but also the desire to also work in an applied field. And for sure, astrophysics is good, but if you were to work with me, you would not be working on astrophysics, but that's okay. You have learned something and you can apply it to something else.
Fantastic. So Nina, same question. Are you also looking for smart people?
Yeah, we have many projects open, so I would like to invite you to visit our booth or virtual booth. DASHH, it's the second booth. I mean, if you go, I mean, to the fair, we have online. Actually, you can have chats with our coordinators of the PhD program. Klaus Erdet and Christiane Erd are actually available for live discussions, not only in the chat, but really Zoom discussions to ask questions for very specific projects. And we have also, I mean, for instance, PIs, so principal investigators and students that have the projects advertised in person, I mean, in scientific talks today. So you are very welcome to join us there. We are looking for, I mean, skilled people and interested people in data science, in applied math, that have, I mean, that are willing to work on interdisciplinary projects. So there needs to be also kind of a burning interest in the physical applications. So, I mean, either you are in favor for high energy physics or material science or theoretical physics, or have always an in-depth interest in developing new imaging tools for X-ray imaging or X-ray microscopy, for instance, then you are the person that should join us at DASHH in Hamburg.
Wonderful, wonderful. As being a physicist by trade myself, I can completely relate. I mean, these are all just wonderful questions, and I think they're perfectly suitable for somebody, even the ones specialized in space stuff. So,
but not yet. But I mean, DESY has projects in astrophysics, no, and astroparticle physics in Zeuthen. So there are actually projects in that area.
Well, maybe astroparticle physics, right? Okay, but let's do a physics conference sometime down the road again, and let's discuss that then. Caleb, if I see in your CV correctly, you're from Australia, right?
Yep, exactly.
That's amazing. I mean, we have a lot of colleagues coming. I mean, they're in bed by now, I think, I don't know. But with your, let's say, experiences coming from farther away, even outside from the European Union, is there something that you could recommend to the rather international audience that's logged in today? What to look for? What are your recommendations for somebody from an international background joining the German research system?
I mean, I had the advantage that I was actually over here for a completely different reason. I originally wanted to study classical dance, and that didn't work out. So I ended up, whilst already being in Germany for 2 years, I made the decision to stay in Germany. Yeah, big career change. So I already had a group of friends and a grounding, and I also was able to, from the start of I did my whole bachelor and master's degrees here in Germany, and from the start I spent a lot of time with the Germans and not as much time with the internationals, which is the main thing I can recommend. Just try to meet locals and try to become as big a part of the German culture as you can. It can be difficult to make friends when you first arrive in Germany. It's a slower process than some other countries, but once you have German friends, then they're friends for life. So don't be afraid to come here. 99% of the people I've met have been super friendly and super welcoming, and it's definitely an experience I can recommend to anybody. It's been great for me. I'm still here for another few years and have no plans on leaving. So yeah, definitely worthwhile.
Amazing. Well, thank you for the recommendations, and I'm very sorry the time is running out, and there is no conference dinner where I could ask you about your dance career. But I'm amazed by the interesting people on our panels. So it's been a great pleasure to have the three of you on the panel. To see such a diverse crowd being tied together by the methods offered by information and data sciences, all applied in numerous completely different but also conjunct fields, so many opportunities for young data science to get involved with. As has been pointed out by all of them, please get involved with their booths on the fair and get in contact, Google them, contact us, and get some more information. So to the panel, Caleb, Nina, Alex, it was a great pleasure. If it were a real conference, we would, how many people applauding?
140.
140 people did listen and are very excited now. And to the rest of you, this concludes the first afternoon session, and we would reconvene at 4:30 p.m. with a nice talk by Uwe Ohler, his career in data science that brought him to be principal investigator in artificial intelligence for biology here in Berlin. So thanks for everyone. Check out the fair, check out the information. Thank you again to the panel, and see you all later at 4:30.
Thank you.
Goodbye. See you.
Thanks, guys. Thank you. It was amazing.